Okay, class, so we've done operations on decimals earlier in the quarter. We've been working with fractions all of the last couple weeks. So today we are going to look at how to convert between the two. So we'll be able to go from decimals to fractions and also from fractions to decimals. So the first one we want to look at is going from fraction to decimal. So to do this, we are going to use our regular long division algorithm, the same one you've been using for years. And there are going to be three types that we're going to look at, and we're going to look at how to spot each of them. We'll have what's known as a terminating decimal, a repeating decimal, and what I like to call a delayed repeating decimal. I don't know if there's a better name for that, but we'll see what I mean about delayed repeating as we get to that one. Okay, so let's take a look at an example of each. So for our first one, we are going to look at the number 1/4, and we want to look at that as a decimal. You might know what it is already, but I just want to show you the process here. So let's see, we are going to divide 1 divided by 4, because remember the fraction bar is just a way to say division. So 1 divided by 4. And we are going to end up using some decimal places here. So I'll just go ahead and add that first one in there because we see that 4 does not go into 1. So I'm going to put a 0 here to start with and move my decimal up. But then 4 does go into 10 two times. 2 times 4 is 8. So we subtract that, and we end up with a 2 left over. And my goal here is to get a remainder of 0. So I'm going to have to make another 0 and bring this down. And then 4 goes into 20 5 times. 5 times 4 is 20. So now we have the 0 remainder that I was looking for, and we can say that 1/4 is equivalent to 0.25. So in writing that is not as bad as mine, we've got 1/4 is equal to 0.25. And this is a terminating decimal because no matter what we do after this, we're only going to be putting zeros on the end of it. We're not going to change the value. So 1/4, 1/2 would be another one. That would be 0.5. Decimals that just end. We can actually find the end of them. That is a terminating decimal. Let's look at one that does not terminate. Let's look at an example of a repeating decimal. And for that, we will look at the number 1/3. So again, you might know this one, but let's look at the process. So we've got 1 divided by 3. And again, I am going to add a 0 there because I'm going to need one. So 3 does not go into 1. So we start with a 0, move the decimal up. Let's see here. 3 goes into 10 3 times. So 3 times 3 is 9. We are going to subtract that 9. And we are going to need to add another 0 here. Okay, so now we look again. 3 goes into 10 3 times. We're going to go ahead and multiply. We get 9. We subtract that 9. There's 1 left over, and we add another 0. And we bring that down. And now we have 10 again. 3 goes into 10 3 times. So notice that no matter what we do, we end up with a 1 as a remainder. We bring down a 0, and then we go into it 3 times, and we end up with 1 as a remainder again. So it's going to just repeat infinitely as many 3s as we can handle, going on forever and ever. And a way to write this would be 0.3 and then we put a bar over the 3, and that means repeating. So that would be 0.3 repeating. It means that nothing happens except for 3's repeating over and over and over again. Okay, so there is a terminating, there is a repeating. Now let's look at one that I like to call a delayed repeating decimal here. So what we're going to do is let's look at the fraction 1/6. So we're going to divide 1 by 6. 6 goes into 1. And like usual, we know that that's not going to work, so we're going to add some zeros. Okay, 6 goes into 1 0 times. We bring the decimal up. 6 goes into 10 1 time. And I'm going to run out of room here, so let me erase some of this stuff from before. Okay, 6 goes into 10 1 time. 1 times 6 is 6. We subtract that to get a 4. And now we add another 0 here because we are looking for either a terminating decimal or we're looking for a spot where it repeats and we can be confident that it's going to keep repeating. Okay, so 6 goes into 40 6 times because we know that 6 times 6 is 36 and 6 times 7 is 42, so it's in between them there. So 6 times 6 is 36. We do have a 4 left over. Bring another 0 down. And we have 40 again. So notice, we've got 40, we're going to get 36, that's going to leave a 4. We're going to have 40, going to get 36, that's going to leave a 4. So no matter what we do, we're just going to end up with 6's after that. But we aren't repeating the entire thing because we've got this 1 out front here that is not repeating. It only happens once. So we need to be careful where we put this bar. We would say that this is 0.16, and then we only put the bar over the 6. So 0.16 repeating. So 0.166666 forever and ever. It's never going to stop because notice no matter how many times we do this, we're going to get 36 and then we'll have a remainder of 4. Okay, so those are the 3 types of decimals that you could get if you start with a fraction. Now let's look at it the other way. What I think is actually the easier way, or the easier out of the two, and that is to start with a decimal and write it as a fraction. So let's go back here. We're going to convert decimals to fractions. And this is where knowing your place value names really comes in handy. If you know the place value names well, then you can do this in no time at all. So let's say the proper name of the number and then write it that way as a fraction. We're just going to write down exactly what we say. So for an example, if we've got 0.26, then if we know our place values, then we know that we've got tenths and we've got hundredths. So we can call this 26 hundredths. Well, we can write that as a fraction. 26 hundredths is 26 over 100. So we're going to write it down exactly like that. And then don't forget to simplify. A lot of times we'll start with whatever we got out of the decimal, but we need to simplify if we can. The greatest common factor of both 26 and 100 is 2. So we just divide both of those numbers by 2 and get a simplified fraction of 13 fiftieths. So 13 over 50. Okay, let's do a couple examples of these. So the first one, we want to express 0.5 as a fraction. Well, I know that 0.5 is the same thing as saying 5/10ths because that first digit past the decimal is the tenths place. So we can write that as 5 over 10. And then I've got a greatest common factor here of 5. So we divide the numerator and the denominator both by 5, and we end up with 1/2, which should be the correct answer. And we got it. Okay, let's try another one. So 0.96. So two places. So this is the hundredths place. So we can write this as 96 over 100. Now, let's reduce this. I noticed that both of these are even numbers, so I'm going to take out a 2. So let's see, if we divide 96 divided by 2, we get 48. And if we divide 50 by 2, or we divide 100 by 2, we get 50. So that gets me 48 over 50. But I noticed that these are still both even numbers. So what I'm saying is if you don't get the greatest common factor on the first try, that's all right. Just keep going. These are both even numbers again. So I'm going to divide by 2 again. 48 divided by 2 is 24. And 50 divided by 2 is 25. And that is as reduced as we can get. So 24 25ths. And we got it right. Let's do one more here. Let's express 0.07 as a fraction. Now, we got to be careful here because we've got just the one number. We've got the 7, but we have to look at where it is. And it is in the hundredths place. So we need 7 over 100 because it is 2 digits past the decimal, 2 places past the decimal. And 7 is a prime number, and 7 does not divide into 100, which means that at this point we're done. So we can't reduce this anymore. We get 7 over 100, hit enter, and we got it right. So make sure you bring any questions about this. We're going to practice doing this both ways, and I'll see you in class.